Welcome, Honors Geometry. We're on Unit 7, Topic 6A1, which is using probability to make decisions. So this is where it usually starts to get pretty interesting for students. We talk about a little bit about betting here. And so there's some fun topics to cover. So not looking at your worksheet right here, just looking at what I have here. You have some ideas, okay? So you roll a dice, okay? So a dice has the numbers 1, 2, 3, 4, 5, and 6 on it, okay? You roll it 30 times. You're going to sum the number of spots that land on the side facing up for each of the 30 rolls. So if you roll a 1 and then a 3, your sum's 4, and then a 4, your sum's 8, and so on and so forth from there, okay? So what's the lowest sum you could possibly get? Okay, hopefully you've answered, get 1 every single time, 30 rolls, that's going to be 30, okay, all ones. What's the highest sum you could possibly get? Okay, so getting 6 every roll times 30, we're going to get 180. So what sum would you expect to get? So here's the word that we're going to be getting at today, but expect to get, okay? So lots of different answers here. Some people just say randomly 100, whatever. But the real answer here should be something like 105, okay? You should expect to get each of these numbers an equal number of times, okay? So if we get 1, 2, 3, 4, 5, and 6 each 5 times, since that's what it would go out to here, okay, you would get 105. Okay, so that would be your what you're expecting to get. Now, here's another example. Again, not on your paper, just looking up here. It works a little bit with your paper, but looking off of this. Bet A pays $20 if you win, and you have a probability of 1/2 of winning bet A. Bet B pays $5,000 if you win, and you have a probability of 1/10 of winning bet B. Okay, how much would you expect to win if you placed bet A 100 times? Okay, so you have a half of a chance of getting this. You pay $20, or you get $20 if you win. Okay, so what you're going to say is you're going to win 50 times. Okay, and then go from there. So you essentially are winning 50 bets, which is $1,000. It's an average of a $10 per bet. Okay, you win $20 one bet, you lose the next bet, you get $0. The average of that is $10. Okay, how much would you expect to win if you place bet B 100 times? Okay, so you're going to win 1/10 of the time. So you're only going to win 10 times out of these 100 times that you roll. Okay, 5,000 times 10 gives you $50,000. Okay, that's going to average out to you have $5,000 that you win every 10 rolls, the $500 per bet. Okay, in placing 100 bets, would you be better off placing bet A or bet B? Hopefully you figure out the answer is bet B. You're making way more money, okay? If you were to be placing 100 bets, okay? You have just discussed the idea of what's called expected value. If you want to highlight it, it's the bottom of your first page, but we will be talking about it again in just a little bit, without even knowing what expected value is, okay? When a random process has numerical outcomes, we are concerned with their amounts as well as with their probabilities, okay? So if you look at the first part on your 761 notes, okay, you're going to see the net winnings. Actually, just go over to this and come back. You're going to see this right here. So we're interested in the number as well as the probability of each of those, okay? So that's what we're saying here. It's important to note that you are generally required to put money down to place a bet and forfeit that money if you lose, okay? So you very rarely end up with the bet that we just showed of $20 versus $0, okay? And you're going to see here in just a second how that changes. Okay, so same bets that are at the top, except we've got that extra idea. Suppose that it costs $5 to place bet A, okay, and it costs $50 to place bet B. Table 1 shows a probability model for bet A, okay? Notice that the net winnings are $15 because if you are going to win this $20, okay, you paid $5, you win $20, that nets out to $15 that you won, okay? And you have a half of a chance of winning that. Okay, the other one is not $0, it's a negative $5 because you're losing that $5 that you're paying, okay, and you have a half a chance of winning that. So we want to do the same thing over here, okay? Our net winnings, so we're going to win $5,000 if we win this one. We're going to pay $50 to place the bet. So our winnings, if we actually win, is going to be $4,950, okay? And we have a 1/10 chance to do that. If we lose, we're losing $50. Okay, and we have a 9/10 chance to do that. Okay, so this is our probability model. So if you're seeing your highlighted information here. That's your probability model that you see in each of those. Okay, so number 2, next you will find the average payoff of the 2 bets over many, many plays. Okay, so bet A produces $15 half the time in the long run and costs $5 half the time. That's what this shows you. So what would be the average payoff? Okay, so the way that you are going to find this average payoff is you're going to say that I'm going to get $15 times half of the time, and I'm going to get a negative $5 times half of the time, and I'm going to add those two things together. Okay, so in the long run, the average payoff is going to be $5. Okay, because both of these are a half, you can actually just look at 15 and negative 5 and say, okay, $5 is in the middle. Okay, but what if these two probabilities are not the same? So looking at table 2 there. Okay, bet this should say B produces $4,950 1/10 of the time in the long run and costs $50 9/10 of the time. So what would be the average payoff here? So if I follow the same structure as I did up here, I can figure that out what that's going to be. So I'm going to get $4,950 times 1/10 of the time, plus I'm going to get a negative $50 times 9/10 of the time. Okay, and then this is going to be my average payoff, which is going to come out, and again, you just put it in your calculator, to $450. Okay, so essentially we should be expecting to make $450 every single bet. Okay, letter C. If you were placing these bets many times, which bet should you choose? Okay, hopefully you figure out you should choose bet B. If you're placing only one bet, which bet should you choose? And in this case, we should talk about placing bet A. Okay, why or explain? There's lots of ways to explain this. Okay, you are more likely to win bet A. So if you're only going to do it once, you're more likely to win that. Okay, but bet B pays better over time. Okay, this may start to give you an idea of why certain people gamble the way that they do. If you have lots of money to gamble, you actually have a better chance of winning more over time, versus if you have less money to gamble, you have less of a chance of winning over time. Okay, if you have a probability model in which the outcomes are numeric, then you can generalize this process that you used in question 2 in order to get a formula for computing the average value, which is referred to as the expected value or mean value. So you can see it as either one of those words there. And essentially, I just showed you that formula with these two. As I took the expected value, so the 15 times the probability of getting that, the 1/2, plus the expected value, which was the negative 5, times the probability, which was 1/2, and you would just keep adding until you've done them all. Okay, so if you want to highlight something else here, we have this idea of expected value and the formula that we are going to use with it. Okay, just an example of expected value from the formula. So suppose you pay $10 to play a game in which you roll a die. Okay, so you could lose $10. If you roll a 4, 5, or 6, you get paid $10, $20, or $40 respectively. Okay, so think about this. If you roll a 4, you're actually paying $10 to play and winning $10. So you're coming out with $0. Okay, if you roll a 5, you're paying $10 and winning 20. So you actually come out with $10. And if you roll a 6, you're paying 10, you're earning 40, you actually come out 30 ahead. Okay, if you roll any of the other numbers, you lose your money. So I'm not minus the $10. And each one of those things are equally likely. Okay, so the way that you would do your expected winnings from this is you would do your negative 10 times 1/6, your negative 10 times 1/6, your negative 10 times 1/6, your 0 times 1/6, 10 times 1/6, and 30 times 1/6, and add all of those together. And in the conclusion, you're expected to win about $1.67. Okay, so really, if you're looking at this and this amount and knowing that you might lose $10, is this worth it? Most people would say no. But that is how casinos make their money. Okay, so I've given you a little bit of information here. Complete the next 3 pages or 2 pages of that worksheet. So part 2, all the way down through question 7F. Okay, and all of the answers are on the Unit 7 answers document.